Hi, I'm Robert Young. I'm a hydraulics product manager here at Harken. The division officially started, I guess, about 2.5 years ago. And since then, we've been designing products, working pretty hard to come up with a variety of custom and production type products to fill our catalog pages. So we'll have a full line of products that will fit from your basic cruiser racer, 35, 40 feet, up to the mega yachts and the Grand Prix maxi boats. Plus 39 was an America's Cup boat we did the cylinders for the 2007 campaign, and a 52-meter designed S&S sailboat, which was built in Turkey, was our first cruising boat or mega yacht powered system. Powered hydraulic systems are something that is getting more and more popular on smaller cruising boats all the way up to the mega yachts. A powered system allows push-button sailing, basically. With hydraulic power, you can run winches, furlers, anchor windlasses, bow thrusters, cylinders, and basically any function on the boat. You can even run the drive system of the boat with hydraulic power as well. It really just depends on how complicated or involved or how little complication you want with the hydraulics. We create power systems that are in our catalog, little small power units to do functions from one single function to 13 functions. Right out of the catalog, those systems are available. But on the larger units where we're using computers and PLCs, which is a programmable logic controller, where we're using those is something that gets a bit more involved. We need engineers that are dealing with those sorts of things on a daily basis. So we have partnered with some local manufacturers and hydraulic innovators to come up with ways to take technology that's used around the world in a large variety of industries, not just the sailing industry, and put that all together into a sailboat that makes everything a lot easier to use, a lot more durable. The biggest issue with the pumps that we've used, and most of us have become accustomed to on boats, is that you push hard in first gear of the pump, and then there's a shift, and then it seems like you're pumping forever to get anything to happen in second gear. The reason for that is there's a big difference in volume of oil between first gear and second gear. So what we decided to do was to go from a standard 2-speed pump, stepping up to a 3-speed pump, which allows us to have a softer step in between, so that in first gear we're actually pumping slightly more oil than the competitors' pumps. Second gear is about halfway in between first and third in our pumps. Third gear is going to be the same pretty much across the board, and the reason for that is it's just a matter of physics, that you can only push so hard to move so much oil. It's just a matter of horsepower, or in this case human power, to push the pistons to create the pressure to move the oil. So we ended up, our first pumps came out as a 3-speed Grand Prix racing pump, about the same weight as our competitors' pumps, but with the feature that they move quite a bit more oil than any of the other pumps. They are auto shift, in other words, so when you get to a set pressure, the pump shifts and goes to the next gear, so to speak, and then it shifts again, goes into the third gear. Those shifts, even though they're automatic, because they're pressure controlled, they are spring operated, which is an adjustment, or has an adjustment. So you can adjust those to your liking based on the boat. So we molded our handles out of long glass nylon, same as we do our carbo blocks, which gives us not only a uniform look with hardware and everything else, but it's a contoured shaped handle. It's shaped in a way so that if it's mounted on the side of the boat or on the cockpit floor, sheets and lines won't get wrapped around the edges of the handles, but also your hands can hold on to them without slipping off. They're lighter than aluminum handles as well. We also designed the handles that can be mounted onto the shafts in 4 directions. So it's 0, 90, 180, or 270 degrees, which allows you to mount the valves in any direction you want and have the handles all uniform throughout the boat. So they can all be pointed forward, up, whatever makes sense for that particular boat. So at the end of the day, we have a valve that is about half the weight of our U.S. competitor for our production type valve, but allows the same amount of flow through the valve, mainly because we've incorporated a few features into one or two features which are patented things, as I said before. It allows us to have less parts, which makes the whole valve a bit lighter and a bit smaller. So as I said, it's about half the weight of the U.S. brands, and size is about half the size as well physically. Our racing version of the valve is totally sculpted. Our Grand Prix versions we cut as much of the weight out of them as possible. Obviously, it costs a bit more because it spends more time on the milling machine, getting carved and sculpted into this miniaturized version of the same valve. That valve actually is the lightest on the market to date, as far as I know, by about 2/3 the weight of our lightest European competitor. So it's we've managed to get quite a bit of weight out and keep all the same functionality as well as the same flows. So that way you can use the same valve at 10,000 psi with the same cylinders and have the highest flow needed for that size. We have made manifolds for these valves that are straight or zigzags. In other words, they one above the other, so to speak, in a zigzag fashion. These also we can do in a sculpted or in a plate version, I guess is what I'd say. The plate version is, or straight non-sculpted is for your normal cruising production type boat, where the sculpted versions, again, cost a bit more because of the time on the machine. We have a variety of different manifolds, from a single up to 9 or so places, already designed and in stock. Other valves we're working on are the double acting valve, which uses all the same features of the single acting, which I just described, but allows the operation of two cylinders pulling opposite each other, or a push-pull cylinder for like a main sheet traveler or jib sheet controls or things like that. We have dump valves, flow control valves. The dump valves we have are mounted in a variety of ways. They're either push button or they're string controlled. The string controlled, you can do it remotely, so if you're sitting up on the rail trimming the main sheet, you can pull a string from there to ease the bang off. They also are designed with flow controls built in, so that you can also adjust the speed of the release. So for example, on a boom bang on a large boat, you may want a faster release or a slower release, so it's just a matter of turning a screw to get the adjustment right how you want it after sailing a few times. So we started from scratch with a clean sheet of paper and said, okay, the only parameters are that our cylinders have to fit within the industry, the sailboat industry standards, meaning loads, pressures, and lengths. And with that in mind, we were able to go out and research different seal materials, different seal types, different types or different style of pistons and applications for these seals. So now with all this research that we had done, we chose a piston seal and a rod seal that we believe to be the best in the industry for the applications we're using. And by doing that, we managed to make the cylinders lighter for the same length and the same strength. We've learned how to make our cylinders much more efficiently as far as material cost and time cost, which brings the price down. That leads directly into the production cylinders, which are not made of titanium. They're made of regular 6000 series aluminum, but that allows us to the designs are incorporated straight over across the board into the other types of cylinders that we do. Standard style rigid boom bangs, air return, but we also do double acting bangs. We're doing bangs with indicators, position indicators as well. A double acting bang is used to hold the boom up hydraulically as well as pull it down hydraulically. A regular air return bang is a hydraulic cylinder at one end with a big air cylinder at the other end. So when you ease out the hydraulic pressure, the boom rises by the cylinder extending. The air pressure inside the long tube extends the cylinder as like a gas shock in the trunk of a car or the hood of a car, for example, that everybody's used in their car hatchbacks for the last 25 years. So a double acting bang works in a way that's more of a rigid type holding power. It's got hydraulic oil on both sides. So what happens there is you pump the cylinder down, but you also pump the cylinder up. Position indicators work with a double-acting vang to tell you where the vang is as far as extension. We're designing and manufacturing a line of hydraulic trimming cylinders. A hydraulic trim cylinder is used to trim the main sheet or jib sheet or whatever feature function you may want to have on the particular boat. That works by extending. As the cylinder extends, it pulls in a multiplied amount of sheet. So most of our standard cylinders will have either a 1-to-4 or a 1-to-6 reverse purchase. So in other words, for 1 foot of travel, it'll pull in 4 feet or 6 feet of sheet. So these cylinders are made in various sizes. They work as a push cylinder, meaning the rod extends. As the rod extends, it actually trims the sail. These are used pretty much on cruising boats with powered systems. Okay. I think I'm talked out on that one. I think basically the customers decided that we needed to offer more in our product selection and have more parts and a more diverse line of products. Not that we didn't have already with the winches, blocks, travelers, etc., etc. So Peter got the idea to find some people who knew a little bit about hydraulics and a lot about having a good time on boats, and so I'm happy to be one of those people, so here we are.